All right, this is the algebra review for Chapter 5. I thought I would work some problems for it. I'm just going to go quickly. This is just reducing fractions, basically, and finding a common denominator. So, for instance, this is Chapter 5 algebra review. Let me write that up here. And we'll do as many as we can get on this video. Okay, so for the first one I'm going to do, I'll just look at number 2. I'm assuming you know how to reduce a fraction on number 1. Number 2, if you think about it, there is a number that divides into 6 and 16. 2 goes into 6 3 times. 2 goes into 16 8 times. If there were an x on the bottom, I could reduce that out too, but there's not, so it would just be 3/8 x. Let's go down to number 5. You have 4x plus 4 over 7x plus 7. Now, if you remember, that fraction bar kind of is a grouping symbol. It divides the top into one thing, and the bottom into another term. So we got to deal with each term individually. When we're trying to reduce these things, the thing we look for is, okay, I'm just going to look at the numerator, the top right now. Won't 4 divide out of 4x and 4? So let me divide it out. That's called factoring it out. If I take 4 out of 4x, there would just be an x left over, and I'm going to put my plus sign. If I divide 4 out of 4, there would be a 1 left over. So I can factor it that way, and the reason I'm factoring it is I want to get all the little factors to see if anything reduces out of it. On the bottom part, I notice that a 7 divides out of both of those terms, so I'm going to take a 7 out. Remember, this is your GCF, and what we write in the parentheses is our leftovers when we do this. If I have 7x and I take 7 out, I have x left. Copy down my plus sign. If I have 7 and I divide 7 out of it, I have 1 left. Don't forget you've got to have the 1. You can't just put x, because if you just put x, you just have 7x when you multiplied it back out. And these two expressions on the bottom are equal. They've got to be able to be equal to each other. Now, you notice that both of these have an x plus 1 in them, so we can divide the x plus 1 out. It's a factor they have in common, so we can reduce it out of the fraction, and our answer is 4/7. Okay, look at number 6. 6 has x minus 7 over 3x minus 21, and when I look at the top, there's nothing that reduces out of it. I'm just going to put x minus 7. Now, if that ends up reducing out of the bottom, it might help me to go ahead and put some grouping symbols around it so I can recognize that it's going to reduce, because sometimes those little things like that can help you see that stuff divides out. If I look at the bottom, 3x minus 21, I go, oh, I can divide a 3. That's the GCF, there's 3. I can take it out of both terms, and if I took it out of 3x, x would be left over. I'm going to have a subtraction sign, and 21 divide out the 3 would be 7. Do you see why I put the parentheses around the top ones now? These cancel out, but if I just had x minus 7, my brain might do some funky things with that. I've seen people do really weird things. Now, is there nothing left on the top since it canceled out? No, remember, if everything cancels out, you can put a 1 there, because I could have said x minus 7 goes into x minus 7 one time, and x minus 7 goes into x minus 7 one time. So on the bottom, I would have 3 times 1 is 3, and on the top, that 1 would have been there. So just remember, a lot of times we don't write it down, but if it helps you to write it down so that you don't go, oh my goodness, there's nothing up there, what do I do? Oh, I put a 0. Sometimes people do that. That's not right, is it? So just make sure you're doing, things that are going to help you develop good habits and actually understand, what's going on with the problem. Number 7, factor here. So even though this is reducing fractions, we're having to remember how to factor here. I have x squared minus 25 on the bottom of my fraction. Now, the top of my fraction, it won't reduce at all. And you know what I'm going to do? Just because I know that if it's going to cancel out, there might be an x plus 5 on the bottom, but it's going to be in parentheses. So I'm going to go ahead and write the top one that way, just so if I have it down there, I'll see it a little easier, okay? Now, when you have two things that are perfect square and there's a subtraction sign in them, that's a difference of 2 squared. And if you remember how to think about these, you say that's this first number squared minus some second number squared, and the first number squared would just be x squared, and the second number would be 5 squared. And how we factor that is we say, okay, there is an x and a 5 in both of the factors, and one of them is a plus and one of them is a minus. And if I remember that that's how I factor that, I'm going to notice, oh goodness, there's some stuff that cancels out here. X plus 5 goes into x plus 5 one time. and x plus 5 goes into this x plus 5 one time. So on the top, I end up with a 1, because everything canceled out, but there is a 1 there. And then 1 times x minus 5 would just be x minus 5. I can write that in parentheses if I want to, or I can leave the parentheses off here because I really don't need it right here. But it wouldn't be wrong to actually write that this way. And you do what you want to do, but that's your final answer there. Look at number 8. Again, I can't do all of them. I'm just going to do some of them, and hopefully this will give you some kind of review on factoring. Okay. Now, remember, the fraction bar splits it into 2 parts. Do each part separately before you try to reduce the whole. Don't start just marking off stuff because you think, oh, that's on the top and the bottom. That would be wrong here, and you'd end up with a wrong answer. If I look at the top, I've got x squared minus xy. Both of those terms have at least an x in them that I can take out. So my GCF is x, and what I would have left out of x squared if I divide x out of it is an x. Then there's the subtraction sign. Now I have this term xy, but I divided the x out of it, so there will be a y left. Okay, so that's the top factor. That's the parentheses right there, not some other thing. I had just put it, and it's a little too far out, isn't it? Now if we look at the bottom, both of these terms down here have a y in them that I can take out. If I have the xy and I take the y out, I would have an x left. I'm going to copy down my subtraction sign. If I have y squared and I take a y out, I would have a y left. And if I look, x minus y goes into x minus y one time, and x minus y goes into x minus 1 one time. On the top, x times 1 is just x, and on the bottom, y times 1 is just y, so that reduces. Number 9 is another factoring thing, and so is number 10. Let me do number 10 and leave you number 9. Can't do them all. And I shouldn't be doing them all. They're assuming you remember this from Algebra 1. It's just that we've got to keep these skills straight, or you'll, reviewed every once in a while, or you'll forget them. So this is your chance to review them. Okay, so I see I've got 3 terms on the top and 3 terms on the bottom, and I know that those kind of things tend to factor into 2 parentheses if they factor at all. On the top, if you think about it, do you remember that we're trying to multiply to get this negative 20, the number on the end, and then there's an invisible 1 that the math guy didn't write in there. We're trying to add to get that coefficient of that middle term. Okay, so what multiplies to give me negative 20 and adds to give me 1? Well, I know that 4 and 5 would be 20. To get a 1 out of that, I'd need a minus 4. Minus 4 plus 5, or 5 minus 4 is 1. Negative 4 times 5 is negative 20. Watch your signs. They're very important, aren't they? So if you remember what we did with those things, it was a plus 5, so I'll put a positive 5, so I'll put a plus 5. And each one of these gets an x, and that's how I factor those out. Now on the bottom, if they factor, each one of these is also going to get an x. But what I'm trying to think on the bottom is I'm trying to multiply to get the number on the end, which is negative 30. And at the same time, there's an invisible 1 there in the middle term that the math guy didn't write, so I'm going to write it down. I'm trying to add to get negative 1. Now 6 and 5 have a difference of 1. If I want a negative 1, I'll need a negative on the 6, because negative 6 plus 5 is negative 1. And then negative 6 times 5, there's 1 positive, 1 negative. They do multiply to give me negative 30. So those numbers right here go here. And it's a positive 5, so we put a plus 5. So now, does anything cancel out? Oh, sure. Look at this. There's an x plus 5 in each one. I could say x plus 5 goes in x plus 5 one time, and x plus 5 goes in x plus 5 one time if I wanted. Here it's not going to make a difference because I've got something left there, so I don't have to worry about what am I going to write on top. X minus 4 times 1 is just x minus 4. X minus 6 times 1 is just x minus 6. I do not have to put these parentheses around these terms. They're connected with the subtraction signs there, so they really don't need it. I'm just going to leave it that way just because I can if I wanted to. One more. On number 12, for instance, they say express the fractions with the indicated denominator. If I had 1 over x and I wanted to change that denominator to have an x to the 4th power in it, what would I multiply x by to get x to the 4th? Oh, I would need an x cubed, x times x cubed, because remember our rule is when we multiply and we have the same base, we add the exponents. Well, if I multiply the bottom by x cubed and I want to keep the fraction equal, I have to multiply the top by x cubed. So on the top, 1 times x cubed is x cubed. They're just asking you to get a different denominator on a fraction there. And one more. I'll pick 17 and try to get through it before I run out of time. Trying to circle which ones I did so I can post on the video what numbers are here. Okay, for 17 we have x over x plus 2. And we have 2 over 3x plus 6, and they want a common denominator. Well, first of all, let's look at this second one. This first one, x over x plus 2, this x plus 2, the denominator, there's no way to break it down any further, but 3x plus 6, couldn't I factor a 3 out of that and I would have x plus 2? So 3x plus 6 is really 3 times x plus 2. Well, I already have the x plus 2 over here. If I need the same denominator, the only thing this first fraction needs is a 3 to make it look like that one. But if I multiply the bottom by 3, I've got to do the same thing to the top. I need to multiply it by 3. So if I want to express those two fractions as having a common denominator, the first one would be 3x over 3 times x plus 2, which I could write as 3x plus 6 if I wanted to. And the second would be 2 over 3x plus 2. And again, both of these could have been written as 3x plus 6 now. But I couldn't really do that at the outset. I had to factor first to see what. The first fraction was just missing the factor of 3. Both of them had x plus 2 in them.